Hello and welcome to my presentation. My name is Abhinesh Prabhakaran. I'm a doctoral researcher at the University of West of England in the Department of Architecture and Built Environment. The paper I'm going to be presenting today is entitled Towards the Development of a Distributed Virtual Furniture Fixture and Equipment Shopping Environment. I'm going to be presenting on behalf of my other co-authors, Dr. Abdul Majid Mahamadou, Professor Lamin Mahadubi, and Professor Colin Abood. As an overview, I'll be giving you a background to the research that led to the development of this paper, as well as the methodology we employed. Further, the key findings of the study and some of the conclusions that we have drawn is also presented in the slide. In terms of the research background, the dynamic consumer behavior, as well as the current state of nationwide lockdown and social distancing mandates, has left the industries like furniture, fixture and equipment sector, also called as FFE, under unprecedented disruption, leaving them on the verge of collapsing. Findings suggest that FFE sector is the hardest hit by the current crisis, resulting in the closure of many stores, including some of the FFE giants like IKEA, Harvey's Furniture, Oak Furniture Land, etc. Statistics also suggest that globally this has resulted in shrinking of compound annual growth of the sector from $731.6 billion in 2019 to $705.7 billion in 2020. The relevance of reviving this sector cannot be overemphasized, considering the contribution it makes to the UK's GDP, which is equal to £12.5 billion, the number of employment it creates in the UK, which is 339,000 employments, as well as UK government's plan to tackle the retail productivity challenge through the initiative called Fixing the Foundation, Creating a More Prosperous Nation. There is a pressing need for FFE sector to change its strategy to connect with the digital native of today by integrating virtual and physical worlds by harnessing emergent technologies into their retail process. Recently, a number of studies have recognized the application of virtual reality in the retail sector, including the FFE sector. However, much of these studies have devoted to the application of virtual reality with a focus on delivering an isolated VR experience or a single user VR environment, which is normally delivered in an in-store VR station, where the role of sales advisors and other family members in a collaborative purchase decision are sometimes completely ignored. Unlike other retail products, FFE products are those items which require collaborative decisions between each members of the family with the assistance of sales advisors before making a purchase decision. Also, as social distancing culture will be a part of the post-pandemic world, where people will have to radically change almost everything, including the way they shop. This means that the consumers will be less enthusiastic about in-store shopping. Studies suggest that 50% of the consumers will be unwilling to visit physical stores in the post-pandemic world. This brings us to the aim of our research. So basically, in our research, a lot of the work we do is based on immersive technology. So what we basically try to do in this research context was to identify whether or not distributed VR, which is also known as multi-user VR, can aid in improving FFE sector's productivity and how these tools should be designed. Thus, we propose a novel methodology for the development and application of a distributed virtual showroom environment called a DVSE for the FFE sector that will allow FFE consumers to shop remotely in a fully immersive and interactive virtual environment, minimizing the risk of physical contact, but at the same time delivering a rich, meaningful and compelling shopping experience that will allow them to have a well-informed and collaborative purchase decision without visiting the physical store. In terms of the methodology, this study was delivered in two main phases: the development of distributed virtual reality environment for FFE, which is the first phase, and as well as the testing of the developed system with the FFE expert, which was the second phase. In the first phase, the 3D models for the FFE environment was developed using Autodesk Revit, which was then imported into 3ds Max to optimize the model for improving the performance. This optimized model was then imported into Unity 3D game engine, and all virtual reality functionalities and interactivity features were added in the game engine. In terms of enabling the distributed functionality, which is also called the multi-user functionality, a photon networking module called PUN was used. PUN is an independent networking engine and multi-user platform, which is fast, reliable, and importantly, they are scalable. Further, networked voice communication that allow users to interact using voice within the virtual environment was achieved using Photon Voice, which can be scaled seamlessly and automatically in the Photon cloud. Through the implementation of these Photon modules, which is PUN and Photon Voice, guaranteed a low latency and short round trip time for the users to transform synchronization as well as voice communication. This is critical in the development of any multi-user platforms like this, as latency can have adverse effect on the user's experience and acceptance of those technologies. In the second phase, the application was tested with FFE experts to ascertain the usability and usefulness by interviewing a group of 9 FFE experts, including FFE contractors, manufacturers, and FFE designers. Having developed the application and tested them among FFE experts, we then sought to preliminarily understand the usability and usefulness of the application, as well as what challenges they pose in the deployment of those kind of application into the market. Findings indicate that all participants had a very positive overview of the proposed application. All the participants considered DVSC as a practical, helpful and relevant application for the FFE sector. One of the key findings from this study is that interactivity offered by DVSC has a significant impact on the participants' response. All participants who used the system identified that avatar representation and voice in the application as a critical engagement factor that delivers a sense of being together in the virtual environment. Also, in terms of the locomotion inside the virtual environment, most of the participants used teleportation as the most acceptable means of locomotion. We also identified some of the critical challenges during the testing of the application, which are a cost of the hardware and software involved, then negative effects in the users like motion sickness, dizziness, nausea, etc. And also another factor we identified was the shortage and additional cost of employing skilled manpower for developing this kind of virtual environments. In terms of the conclusion, the proposed system is highly useful and an effective tool for improving FFE sector. All participants agreed that the application is practical, helpful, and relevant for the FFE sector. To alleviate the key challenges we identified in this study is to use future developments will target on using low-cost head-mounted displays like Oculus Quest for deployment of these kind of application, as well as special attention to framework and frame rate enhancements through techniques like baking, occlusion culling, etc. will be implemented. This will reduce the negative effects like motion sickness, dizziness, etc. to a certain limit. Also, for the industry to implement this kind of similar applications, certain factors need to be considered, because while developing this application, we used Autodesk Rivet and some other middleware applications like 3ds Max, texture enhancing softwares for getting high visual fidelity. So it has gone through a lot of iterations before they are being imported into the Unity game development engine. So all this software cost, additional time required, these factors should be considered by the industry for the future development of this kind of applications. That is all about my presentation. Thank you for your time.